I got some questions about homework B, and I thought I should prepare a little short video, a few minutes, to help explain how to set up for B. And if you listen to the video all the way through, you'll find a little surprise hint on the third problem in the set. Now, when I talk about the derivative trick, I sometimes say alpha instead of A. I mean the same parameter. One year I used alpha, this year I'm using A. So just disregard that there is no difference. It's the same parameter. We've gotten several questions on homework B1, which is to use the derivative trick. You can see here differentiation is down there. So let's go look at the notes, the textbook, and see how we handle this. So we have something with an exponential, and we want to be able to put in an x to the n in there like that. So let's look at the derivative trick. Here we have, if I were to make this look more like the homework problem, say I have some kind of an integral without the x in there, say I have this, and I want to prepare it to be able to do something like this. So you have this bare exponential, but you really want to put something in there like x to the n. So we'll first consider like maybe just n equal 1 or something like that. In this case, we want n, well, it'll be 2. You want ex squared. So what you do is you can't differentiate with respect to x because that would mess up everything. You know, x is your integration. So you want to introduce a parameter a where you can take a derivative. So I want to put an a up in there like this. You see the minus a x squared. And I know this integral, and that's like one you can do when you put like, see, your a in there, you're going to be able to do that integral. So just like we're following the book here, like an analogy. So we have a different exponential. Let's work with the one in the book. So here, to get a higher power, see if x in front, in this case, you would take a derivative with respect to a. See, I pulled down the x squared, or since you pulled down a minus x squared, you want to take negative the derivative with respect to a. So taking a negative derivative with respect to a pulls down the x squared. So let me go ahead. See this here, if you do this, you will get the integral where you pull down the x squared. And that's the integral I want to do, where a is equal to 1. You always set a equal to 1 at the end. So I want to do that integral. But I can do it now by taking the derivative of this. So taking negative the derivative of this, which we then, have it worked out here, then all you have to do is let a, here it says, let a equal to 1. And when you do that, then this becomes here 1/2 times the square root of pi. And that then gets you the integral you wanted to start with. Now, what you want to start with is actually x to the n. But look at this practice problem hint. Take derivatives over and over again. In other words, if you did the same thing again, you pull down an x squared again, then you're going to be able to do, see, x to the 4th. And here you'd want your alpha in there because this would be your alpha. You have to have it in terms of alpha so that you can take the derivative of the answer in terms of alpha and get the next case. And then at the very end, you're going to let a equal to 1. And then if you take the derivative, say the third derivative, you would have an x to the 6th power. So here in this problem, you would take the derivative n times. So I'm going to write this as a little n there. So taking derivative minus the derivative with respect to a n times will get me this. And that's how you can get the general answer. So over here, the same idea, you put that alpha in there, just like by analogy, you have a little different exponential, but it's the same principle that is done here. The same idea. And that will get you the general formula. Like you just take the derivatives over and over again. Now you can, do maybe 3 cases and psych out the pattern. And then you could write down the nth case. So you're interested in doing, well, actually you're interested in going from 0 to infinity of x to the n, e to the minus x dx. And remember, you're going to want to put that a in there, because unless you have that a in there, you're not going to be able to do anything. The derivative trick means take a derivative with respect to something else, not x, because that's going to mess up. You can't mess with x. So you have to have another parameter. Once a Caltech friend told me that the professor had something like e to the I, like pi theta or something like that, and wanted to pull a theta down, and the professor said, take the derivative with respect to pi. Now, it's kind of, that's kind of like a joke, because pi is a constant, but in a sense, it's the similar idea. If you have, this a parameter, think of that pi as a parameter, you could take a derivative with respect to pi and pull down an I theta. So I thought that was a cool joke. Okay, so good luck with that, and we'll hopefully that will set you up to work on the homework problems. And I believe that's similar to problem B2. And if you look at B3, and if you're clever, actually a derivative trick will work with B3 also if you use a formula we derived in the book. We have, you can use something that's already derived in the book, and then if you apply the derivative trick on that, you can knock this one out in one line. Good luck.